Okay, let's take this to the next step. And what we've been doing was a moles to moles conversion. And that was a real simple setup because let's say that we had, here's an equation that we used yesterday, N2 plus 3H2 yields 2NH3. And these coefficients tell us how many moles. This says that we need 1 mole of N2 to react with 3 moles of H2, and when you do that, you get 2 moles of 2NH3. So a question that you could have expected me to ask was, how many moles of H2 are required to react with 5 moles of N2? And the way we set this up is we'd say, okay, well, here is what we are trying to find out. How many moles of H2? And here is, let's highlight this, how many moles of H2? And here is what we know, is that we have 5 moles of N2. And so we'll highlight that we have 5 moles of N2. And so that means that we're going to use this format that we've been using. How many, let me make that bigger. How many moles of our unknown are equivalent to however many moles of our known that we have, multiplied by the conversion factor, where we have moles of the known on the bottom and moles of the unknown on the top. And then we would just simply plug in the ratio from our equation. So if I was going to answer this question, I would say how many moles of H2 would be the equivalent, or to react with 5 moles of N2. Well, 5 moles of N2 is our known, so we'll put moles of N2 on the bottom. We want to find H2, that goes on the top. And according to the ratio from the balanced equation, 3:1. So we multiply across the top, divide by the bottom, and of course our answer is 15 moles of H2. But what if it was asking us to go a step further? What if it wasn't asking for moles? What if it was asking for grams? And that means that this setup would look a little different. We'd say how many grams of H2 would be equivalent to 5 moles of N2. So this is what's called a moles to mass problem. And it's fairly straightforward because everything's exactly the same. We're going to add one step. Obviously, we want to find moles of H2 for moles of N2. So this looks exactly the same. And the ratio hasn't changed, 3:2. The only thing that's different is finding grams. So what I'm going to do is I'm simply going to add one more conversion. And that conversion is going to say, well, if we know that we have 1 mole of H2, how many grams of H2 is this? And since we know the molar mass of hydrogen is 1 gram, actually, excuse me, since there's 2 of them, there's 1 hydrogen, would be 1 gram, but there's 2 of them, so of course that's 2 grams. Then how many grams is this? Well, it's 15 moles of H2, and the molar mass is 2 grams. That means 30 grams of H2. And that's all that you do. So let's put together a little plug-in kind of dealie that we can use, just, kind of guide us as we go. So let's say that we're doing like this one that we just did, which was a moles to mass. So what would the basic setup look like? Where the unknown is a mass and the known is moles. We'd say how many grams of our unknown, because that's what we're trying to find, would be equivalent to however many moles of the known that we have. And then our table would look like this. Remember that the first conversion factor, the one that goes on the bottom, is always the same as the one that you're starting with. And that we could easily convert 2 moles of our unknown, and we would just use the balanced equation. And then how do we get from moles of our unknown to mass of our unknown? Well, that one's pretty easy. Do you remember this guy? How do we go from moles to mass? You just need to find the molar mass of whatever it is you're looking for, and that's what your periodic table's for. So that means that in this blank template here, this would be molar mass, and this would be 1. Let's try another one going the other way. Let's try another one. Let's try the same equation because we're pretty familiar with it by now. And let's say that we were going to ask a question that looked like this. How many moles of NH3 could you get from 20 grams of N2? Notice if we're looking at this that our unknown is here, and it is moles, and that our known is here, and that it is grams. So this is what's called a mass to moles problem. How are we going to set this up? Let's come up with a blank version. Let's say that our unknown is how many moles of our unknown, and our known is a certain amount of grams. What we're going to do is we're going to say, well, look, we got to get out of grams of our known. Remember that these two are always going to be exactly the same. So we want to get out of grams of our known to moles. We'll put moles on the top. Well, how do you get moles from grams? How do you go from mass to moles? And that's what this guy tells us, mass to moles. Molar mass is on the bottom, 1 mole goes on the top. So let's put molar mass here on the bottom. Remember that these two are always the same, so this is going to be molar mass, and that will be 1 mole. But that only does it with our known. We want to compare the moles of our known to the moles of our unknown. And so we'll just add one more step that uses the equation and the ratio from our balanced equation. So now that we have this, let's see if we can answer this question. How many moles of NH3 could we get from 20 grams of N2? So notice that I'm setting this up just like this template, where I'm starting with my unknown. How many moles of our unknown are the equivalent of our mass of our known? So the first thing that we're going to want to do is find the molar mass. You'll notice I switched periodic tables. That first one didn't have molar mass on it. And check this out. If you have 1 nitrogen, that's 14 grams. Well, this is 2 nitrogens. So we'll take that 2 nitrogens and we'll multiply 2 by 14. And this is 28 grams of N2, 2 times 14. That gets us into moles. Now, all we got to do is go from moles of N2 to moles of NH3. Balanced equation is right there. It tells us that 1 mole of N2 for every 2 moles of NH3. So we'll plug that right in there. 2 to 1. Now, if you show up without a calculator, you're going to be in bad shape. And I'm going to bust out my fancy one because it's always here and the batteries never run out. So I'm going to say 20 divided by, well, let's multiply across the top. So times 1, we don't really need to do that, but that's okay. Divided by 28 times 2. How many moles of NH3 could we expect from our 20 grams of N2? 1.43 moles of NH3. All right, so that's all you have to do. I'm going to ask you to try a couple of these, and I'll make sure that these blank templates, this one and this one, are right there so you can plug everything right into it. All right, take it for a spin around the block for me, would you?